Hi, so in this class, we will talk about what is an electromagnetic wave energy, that is EM wave energy. And there are three concepts that we will cover. First is electric energy density, we'll know what is it, magnetic energy density, and based on that, we'll derive the value of constant C, which is the speed of light. We have seen that earlier. So first is what is electric energy density is basically tells us the strength or the magnitude or the maximum energy contained in an electric wave, that is the electric field. So you can say that electric energy density tells us the strength of electric field. Similarly, magnetic energy density signifies the strength of a magnetic field in the magnetic field, in a magnetic wave. So there are formulas to do that. So first we will say that electric energy density, let us define it with a value. We can say that which is equal to 1 over 2 epsilon naught E square, where E is the electric field, epsilon 0 is the permittivity of a free space, and magnetic energy density can be given as 1 over 2 into mu naught times B square, where B is the magnetic field, mu is the permeability, and third is the derivation of the speed of light. We'll see how to derive it. So we basically, with these values, we can say that the total energy density can be a sum of this component. This is component number one, this is component number two. So it will be half epsilon naught E square plus 1 over 2 times mu naught times B square. And we will say that this is equal to U. So which is the total energy density. So this says that the total energy density is the strength of the EM wave, electromagnetic wave, which is the composition of the energy density of electric field and the energy density of magnetic field. So that makes up the EM wave. And know that these two components are equal to each other. So we can read or we can write here half epsilon 0 E square is equal to half 2 times mu naught B square. So we say that this EM, electric energy density, is equal to the magnetic energy density. So if we have that kind of relationship, we can write the value of U to be equal to, we can just plug in this value or this value in the above equation, and we can get the values like this: epsilon 0 E square, right? Because we can write 1 over 2 times mu naught B square to be equal to 1 over 2 epsilon 0 E square. So with that, U becomes this. Similarly, if we can write U equal to, uh, we can write that 1 over 2 mu naught B square, because we can replace this with this value, plus 1 over 2 mu naught B square. So that will be equal to 2 times 1 over 2 mu naught into B square. So 2 gets cancelled. So it will be 1 by 2 uh, times mu naught. Let me write it here. It would be like undo or eraser. it would be then, you can say that U will be equal to 1 divided by mu naught times V square. So either the total energy can be represented by this equation or by this equation. Okay. So now we have, let us write here, we know that epsilon 0 times E square is equal to 1 by mu naught. This, let's say 1 by 2, and this is also 1 by 2 times B square. We multiply both sides with 2, so we'll get these values, 1 over mu naught times B square, and we take a square root of both sides. Take square root of both the sides. So with that, we will see that we can write this as E equal to 1 over epsilon 0 mu naught and the square root times B. Okay, so we just take the mu naught here first and then take the square root of both the sides, and we come to know this equation. Now we know the values of epsilon 0 and mu naught. So epsilon 0, somebody, let's say, did a electric experiment and the value of it can be written as square root 8.85 into 10 to the power minus 12 farad per meter. And mu naught is also a value known to us because they are constant, and they have been, these values of these constants have been obtained by performing electric experiment and the magnetic experiment. So it is this one, this is, I think, Weber per meter. Okay, and multiplied by UB. So now you see this value is a constant here. So you can actually see that this value particular is constant, and we can calculate that value. And once we know that, we will see that E comes to be equal to C times B, and C is equal to 3 into 10 to the power 8 meter per second. Okay, so we say that, so because if we calculate this constant, that comes out to be 3 into 10 to the power 8, and that value is nothing but the value of C. So we can write that, okay, E is equal to C times B. So electric field is equal to the magnetic field multiplied by the speed of light, which is known. So remember, C value can be derived, and it is equal to 1 over square root of epsilon 0 times mu naught. So this is how we have derived the expression for the constant, which is C, and at this speed, the EM wave propagates into the space.